Hey there, my name is Gary Sims and this is Gary Explains. And what I have here is the Arduino MKR1000 microcontroller board with built-in Wi-Fi, and it costs around $30 or 30 euros. And what I have here is a Raspberry Pi Zero that costs only $5 or 5 euros. 35. So the question is, why would you use one of these rather than one of these? If you want to find out more, please let me explain. So let's start with the Arduino. Of course, it is a complete ecosystem. That means you get the boards and the software development environment. There's an online community, there are clone boards, there are extra libraries, third-party libraries, and the community is very much alive and still growing. So this board here is an official board from Arduino. That's the MKR1000, got a microcontroller on it, Cortex M0 microcontroller, and also it's got Wi-Fi. Now, of course, there are lots of different types of Arduino boards. For example, you can get an Arduino Every Nano. That'll only cost you $10. You can get the classic Arduino Uno. That will cost you maybe $20, but you'll have to add networking to both of those with some kind of add-on, some kind of shield, we would call it like that. And of course you can get clones. So for example, you can get a copy of an Arduino Uno clone for maybe only $5, but that may have to get shipped from China. You may have taxes to pay, but the clone ones are actually incredible value for money. And then there are kind of compatible boards. For example, you can get the ESP32 based Arduino compatible board. They have Wi-Fi built into them, and you can get those again for maybe about $8, 8 euros, again, depending on where you are in the world. Now, those are all rough prices. There are, of course, sales and discounts, and it depends on your currency and your location and all that kind of stuff. That's kind of a rough guide for you. Now, all of those are microcontroller boards. That means you're not going to be running something like Linux. You're going to be running some kind of microcontroller operating system. Arduino is itself its kind of full system, including all the libraries. It can do lots and lots of things built into that. You could maybe try other operating systems on them. So it's a microcontroller, and you're going to be looking at maybe, for example, 48 megahertz as the speed, with maybe 32K of storage, 8K of RAM. It really does depend on the board and the combinations, but we're looking at very small amounts of RAM and small amounts of internal storage. Now, on the other side, we have the Raspberry Pi. Now, again, the Raspberry Pi is an entire ecosystem. You've got hardware boards, you've got a software maintained by the Raspberry Pi Foundation, there are online communities, there are third-party libraries and applications. So, and again, very, very much alive and growing. Now, this is the Raspberry Pi Zero, which is the smallest of the boards from the Raspberry Pi Foundation. Now, you get two varieties, the Raspberry Pi Zero and the Raspberry Pi Zero W, and the W1 has built-in Wi-Fi networking. And one of them, the cheaper one without networking, costs you $5, and the W, the Wi-Fi one, costs you $10. And the big difference, of course, is this is running a full multitasking operating system in that it's running Linux. In fact, on here is an ARM v6 processor, single core, running at 1 gigahertz, and you've also got 512 megabytes of RAM. So again, the difference between maybe 32K, 48 megahertz to 1 gigahertz and half a gigabyte of RAM. So very much different systems, but the prices, in fact, this is probably one of the cheapest boards that you can get. But from any microcontroller or any kind of board, this really is an amazing price at $5 or 5 euros. So what are the main differences? Well, as I said, because one is running a small amount of memory at a low clock speed, running a very simple operating system, and the other is much more powerful with a full operating system, much more memory, and in fact you can have as much internal storage as you like. You can add SD cards, 4 gigabytes, 8 gigabytes, 64 gigabytes, whatever you need you can add on there. And actually that shows that one system is much more simplistic than the other. Now, you may think that if something is simplistic, that means it's bad. You'd rather the more complex system, more comprehensive system. Well, actually, when it comes to doing kind of your own projects, it really does depend on what you're trying to do. So, for example, if I wanted to build a small circuit, I don't know, temperature control or some kind of control for my lights or something like that, I want something that will boot up very quickly and doesn't really have a problem that there could be corrupted memory, corrupted internal storage. Now, for that case, you really do need a microcontroller board like one of the Arduino boards. They boot up in just a fraction of a second, and the flash program that you've put on there really is very difficult to corrupt it. Even when you turn the power off, it goes on and off. There's no proper shutdown. You just turn it off. It doesn't matter. It kind of can survive all of that because it's really a read-only memory. It loads in the what it needs to do to run this little thermostat or little project that you've got going. Whereas on the other side, a Raspberry Pi is actually much more complicated in the fact that it takes a long time to boot. It might take a minute or a minute and a half to boot up. And also, because you're using that SD card, if you just turn it off without shutting it down, there are dangers of it being corrupted. Now, I've actually been using a Raspberry Pi for one of my projects in the house, and it gets switched off just randomly because of power failure or because I just pull the plug out the wall because I want to do something else. And it has survived, but there have been a few occasions when I've had to reinstall the software onto the flash card, or maybe even change the flash card because it got corrupted, it got worn out, whatever. So if you're looking for something that's instant boot and just does what it's meant to do without that worry that it's going to go wrong, then that's why you need a microcontroller board, for example, like the Arduino. But by the same token, if you want to do things that are more complicated, for example, computer vision, or you want to run a comprehensive website with images and audio files, if you want to do recording of data, whether that's video clips or the data you're getting from your project, you want to be able to do things on kind of with email, and you want a Linux system that can give you all that complexity and variety, then of course you need a more complicated operating system, and that's where a Raspberry Pi would be much more suited. So for example, while it is possible to create a small web server on an Arduino, and in fact I've got a whole video about that which I will link to somewhere up here in the top there. Okay, that is actually, it's pretty much hard coded. It's just you write it yourself. It can deal with a few discrete things, very specific things. But if I wanted an actual full-blown web server with JavaScript and PHP and whatever else I wanted to do in the background, Python, however you want to develop that thing, then of course that would be better suited to a full development environment that you can get on an actual Raspberry Pi. And actually, to that end, you can actually log into a Raspberry Pi because it's Linux using secure shell. So you can log into it, remotely administer it, change things. In fact, update the software, modify what you want to do. Whereas really on an Arduino, you don't log into it, you don't do updates by logging in and then saying here's a new version of the website. You might have to flash new program onto it yourself, plug it into the USB again. So it's much more remote on the Raspberry Pi. You can connect into it, you can do all your Linux administration tasks, whereas on Arduino it's much more simple. It's there, you've flashed the program onto it and it just keeps on running. And because the Raspberry Pi is more complex, you can connect a mouse and a keyboard and a monitor to it, and you can get a whole desktop, a Linux desktop. You can do remote desktops through VNC and things like that. Now, I'm sure there are some different connectivity solutions available for the Arduino, but we are talking about the difference between a multitasking, multi-user operating system with a desktop, mouse, keyboard, big monitor. In fact, on the latest Raspberry Pis, the Raspberry Pi 4, you can connect two 4K monitors to it. It's very much a different category of equipment. But in terms of interacting with other electronics, both boards are equally capable. You've got pins that can be used for digital I/O, so you can turn them on, you can turn them off, you can read digital signals on them. There are analog signals that you can read, there are analog pins you can control. There's obviously 5 volts and ground, all that kind of stuff that you need for making digital circuits, and you can control them equally on the Arduino as well on the Raspberry Pi. So when it comes to actually doing something, then you could do it on either. In fact, I've been fiddling with a kind of a little LCD display. You may have seen some of my pictures on Instagram about that. And I actually had it working on both the Arduino and the Raspberry Pi. They both have libraries to support kind of things like temperature sensors and the LCD displays and anything you kind of buy. You can buy it, and there's really the libraries available for both ecosystems and pretty much well supported across the board. When it comes to writing programs for these two systems, on the Arduino, you're basically writing using the Arduino IDE, which is a C compiler. There are some differences, but basically it's a C compiler. You write your program, and then once it's compiled, you kind of get this firmware that you put onto the Arduino, and it boots up directly into that firmware. On a Raspberry Pi, you've got everything you could ever want. You've got C, you've got C++, you've got Go, you've got Rust, you've got Python, you've got, you name it. You know, if it's available for Linux, it's going to be available for the Raspberry Pi. So if you are particularly good at writing in one particular language, you have experience with that, that's not C, then of course you can do that on the Raspberry Pi. For example, let's say you know some Python, and then you can control the input-output pins using Python. You can write web server, you know, you can do everything in basically a whole multitude of different languages and development environments. In fact, talking of Python, there are some alternatives to the Arduino setup. For example, there is CircuitPython, which is something that comes from Adafruit. And I do have a Adafruit Trinket M0, and I'm going to be doing a whole video about CircuitPython. So that kind of allows you to take something like an Arduino style board and just write Python code for it if you're not actually any good at writing C code. So do watch out for that video that will be coming soon. And when we're talking about just general microcontrollers, there are alternatives to just the Arduino system. There are things like Zephyr and FreeRTOS and Mbed OS that are also able to be used on a whole variety of different boards. In fact, I've got a couple of videos coming up, one about the blue pill, the STM32 blue pill, about how that can be set up and used, for example, using Mbed OS. And I also have, if you followed me on Instagram, you'll see some photos that I've posted about how you can build an Arduino-like microcontroller board just from the raw components on a breadboard. And again, I'll be making a video about that. And again, I'll be showing you the tools that I use to write the software for programming such a board. And the final thing to look at is power consumption. Now, when you boot up a Raspberry Pi Zero with a mouse, a keyboard connected to the HDMI, it can run at about 200 milliamps. In fact, you can even peak at 300 milliamps. And of course, it very much depends on what USB peripherals you've got connected to the device. On the other side, an Arduino will be running at about 10 milliamps. So you've got 10 milliamps versus 200, even 300 milliamps. Now again, both are dependent on what you're trying to power, but if you're assuming that you're using external power for any complicated circuitry through relays or whatever, then the actual board itself, 10 milliamps, even less than 10 milliamps I measured on the Trinket M0, compared to 200 or 300 milliamps. So a big difference there. So really, if you were doing a Raspberry Pi kind of project, you would want it plugged into the mains using kind of a USB adapter. If you're doing an Arduino, there are many of the boards come with battery connectors, so you can stick in batteries in battery holders. Some of them even use those coin-sized CR size batteries. So it's a different kind of realm in terms of power consumption. Now the good news about the Raspberry Pi is if you do disconnect the USB peripheral, so you have no mouse, you have no keyboard, that power consumption does drop down to about 80 milliamps. So then it's a difference between 10 milliamps and 80 milliamps. Again, a significant difference, and it just depends on what kind of project you are trying to do. Okay, so that's about it. So in summary, the pricing is very, very competitive on both the Raspberry Pi and the Arduino, depending on where you buy it from, what you're buying, and so on. Secondly, of course, there is a big difference in terms of the complexity. The Raspberry Pi is full Linux, desktop, network connectivity, all that kind of stuff. Arduino, lower clock frequency, 48 megahertz, 32 K, much smaller system, but therefore simpler and quicker to boot and more reliable, not susceptible to SD card corruption or anything like that. And then of course, finally, you've got the whole different programming languages. Really, it's the Arduino IDE on the one side, although there are other things you can use. Whereas in Linux, of course, it's anything you can get for Linux, C and Go and Rust and Python and whatever you like, Java even, you can use that there on the Raspberry Pi. And power consumption, well, there's more power is used on the Raspberry Pi compared to the Arduino. Okay, I hope that's been useful for you can see the difference between these two things. It's not only just about the cost. The cost is one part of a bigger equation when you're looking at what you want to use for your project. Okay, my name is Gary Sims. This is Gary Explains. I really hope you enjoyed this video. As I mentioned, I've got some other videos coming up about microcontroller boards, about Arduino stuff, so do stay tuned for those. Okay, that's it. I'll see you in the next one.